Okay, I think I have everything working now. Thanks again for joining me today for another Advent of Code. I'm feeling a little under the weather, so I'm not feeling up to having my unfiltered webcam, so I'm going to be joining you from the Matrix today. So with that, let's go ahead and get going. Let's transition over here. All right, day 7. Let's do this. Day 7, no space left on device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get out here, anyway? The device the elves gave you has problems with more than just the communication system. You try to run a system update. System-update, please, pretty please with sugar on top. Error, no space left on device. Bummer. Perhaps you can delete some files to make space for the update. You browse around the file system to access the situation, or to assess the situation and save the resulting terminal output, your puzzle input. For example, we've got CDs, we've got LS, dir A. Okay, interesting. We've got a bunch of CDs and LSs. File system contains a tree of files, plain data, and the directories which contain other directories or files. The outermost directory is called slash. You can navigate around the file system, moving into or out of directories and listing the contents of the directory you're currently in. Within the terminal output, lines that begin with the $ are commands you executed, very much like some modern computers. CD means to change directory. This changes which directory is the current directory, but the specific result depends on the argument. CDX moves in one level. It looks in the current directory for the directory named X and makes it the current directory. CD ... moves out one level, finds the directory that contains the current directory, then makes that directory the current directory. CD/ switches the current directory to the outermost directory, slash. LS means list. It prints out all of the files and directories immediately contained by the current directory. 123 ABC means that the current directory contains a file named ABC with size 123. dir XYZ means that the current directory contains a directory named XYZ. Oh, okay, I see. Given the commands and output in the example above, you can determine that the file system looks visually like this. Here there are 4 directories, slash, the outermost directory, A and D, which are in slash, and E, which is in A. 4 directories. Oh, right, because these aren't directories, that's what they're saying. Okay. These directories also contain files of various sizes. Since the disk is full, your first step would probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of the files it contains, directly or indirectly. Directories themselves do not count as having any intrinsic size. The total sizes of the directories above can be found as follows. Total size of directory E is 584 because it contains a single file I of 584. That makes sense. The directory A has a total size of that because it contains F, G, and H. Right? Plus file I indirectly because A contains E, which contains I. Right, okay. Okay, directory D has a total size of that. Okay. As the outermost directory / contains every file, its total size is this, the sum of every size of every file. To begin, find all of the directories with the total size of at most 100,000, then calculate their sum, the sum of their total sizes. In the example above, these directories are A and E. At most, okay. Sum of their total sizes is this. As in this example, this process can count files more than once. Right, okay. At most, okay. Find all of the directories with the total size of at most 100,000. What is the sum of the total sizes of these directories? All right, let's see. Oh boy, this is fun. This is a lot of input. So we're going to be building a tree structure today. Let's take a look at here and go to 07. Okay. And create input.txt with all that. And then let's grab some of the example input and output. So this is the only example we have so far. So let's throw that in here. We'll say no one can call me during this. .1.input.txt and example.1.output.txt, and the answer is this. Gosh, who wants to talk to me right now? Okay. All right, let's do, what language am I doing today? Should I do PowerShell or should I do JavaScript? I will do JavaScript just because I can tell there's going to be some string parsing involved here. Well, it won't be too bad. I don't know. We'll see. With me feeling under the weather, I'm going to go with something that is completely within my comfort zone. Maybe I can be a little more adventurous later on once I get feeling better. So first things first, we need to parse the input. And I'm imagining here that the parsing is not going to change from part to part. So I'm going to start out with the function to parse the input. Okay, so what do we need to do here? Let's pull this over to the side and take a look. So we have a few different options here. Do we start at the root every time? Let's see. If we go and look at here. It looks like you do start at the root and start traversing that way. So we could just start building up kind of well, we don't even need to make it a tree. We could just have it be like an object hash where the key is the full path of the directory and the values is a string array of items within that directory. Well, maybe not even a string array, like an object array. So let's try doing something like that. So we'll say for each let's start out with our file system, and it's just going to be an empty object for now. And if I was doing this in TypeScript, I'd probably type it something like this. I'm going to make it a record type, and the keys will be strings for the directory path, and values would be something like an object type. It's going to be either a file or directory. Name would be a string, and size would be a number. So something like that. That's the direction I'm going here with this. So let's try this. So we need to keep track of which path we were last looking at. Alright, so we've got an ls command. Got a cd command. Okay. So basically, first we want to say, is this line a command, or is it output from a command, right? So we can do this by doing something like so we can say is command equals l dot starts with a $sign. So that gives us whether or not it's command. So we can say if is command, then we want to basically parse the command, right? So then a cd command would have a, let's say that we split this on the space. You'd have 3 items in your array. You'd have the $, the CD, and the slash. In fact, it looks like it's going to be useful to split this on space regardless. So we'll just say like const, brain's not working today. We'll call it parts equals dot split on the space character. Then I can say parts at 0 is going to be equal to $. Okay, so if it's a command, and we will have an else for sure, but if it's a command, we need to determine which command it is. So we'll say, is this a change directory command or is it an ls command? And it looks like you can't specify like an absolute path. You're either going in or out, which makes me think that your navigation can be represented as a stack, kind of like we did in the crates problem a few days ago. Okay, so maybe we can say const navigation stack. It's going to stay empty until we get a cd command. Okay. Great. And maybe we can even create like a little function that will tell us what our current working directory is. So we'll say const cwd is going to be get the navigation stack and grab the item at the end, which is going to be navigation stack.length -1. And this arrow function will implicitly return because we don't have any curly braces. So we can always call cwd. Okay. I wouldn't be surprised if the directory names are not unique in the actual input. Like there may be a directory several levels inward that has the same name as one on a different level. So we definitely want to get the entire path. So let's see. Full path would be grab the navigation stack and let's join it with a / character. Now that's going to be a little bit weird because if the first item in the navigation stack is a /, then we'll end up with 2 slashes at the beginning. And I guess that's something we can just look out for. But as we're pushing things onto the stack and popping them off, just need to be careful of that. Okay, so all right. So if we've got a command, we've got cd/, right? So cd/ is going to basically empty out the navigation stack, right? So we would have, maybe we just call the root empty string, and we can cd into that, I guess. File system. But if we're going to do that, we need to do something like this. Empty string is going to equal an empty array. Okay, so the navigation stack, if it's empty, we know that we are doing this because the full path, when you join an empty array, should be an empty string, right? If we try this, we say we've got A, B, and C. We say join with the slash character, we get ABC. And if we have an empty array and we join it, then we get nothing there. Okay, so I think this should work. Yeah, let's just see how this works here. Okay, so we would say const command is going to equal parts1. We say if, I mean, honestly, like, I don't know that the ls command really does much here for us, because we know that if we're not doing a change directory, I mean, if we're doing a non-command, it's always the output of an ls. We don't even care about ls because we grab something that's not in the, that's not a command, and we know it's an ls result. So actually, I'm just only going to care about if that command is a cd. Command equals cd. And in that case, we want to, man, I'm getting a lot of nesting in here. I'm going to have to clean this up. If, so we would say const dir is going to equal parts at 2, and if dir is equal to slash, then, and maybe we just do this as we make this a let so that we can empty out the stack. We say navigation stack equals empty array. Else, oops, navigation stack dot push dir. Okay, so let's walk through this. So we've gotten part 0 is $1. So then we come in here, if there's a CD after it, then we have 2 options. Oh, but we didn't code in the option for going up a directory. So else if dir equals ... then we want to say navigation stack dot pop, right? Okay, so we go into slash, which empties out our navigation stack. Oh, CWD is going to bomb. I probably need to say like navigation stack dot length is greater than 1. If so, then we want to do that. Otherwise, we return that. There we go. Okay. And actually, I don't know if I care about the current working directory as much as I do about the full path. And we'll see. Okay, so we go into the root, which empties this out. We're going to get, we're ignoring the ls. So that will just, it'll go into the is command, and then it won't pass this, and so it just drops all the way out and goes to the next line. Okay, and then we haven't coded our else yet. Let's just kind of do the traversal. So CDA, it's not a slash, it's not a dot, so we're going to push A onto the stack. So we would have just a single element A there. And then next we do CDE, so we would push E on there, so we would have A slash E. And then we would go back 2 levels, so that pops off both of those. We're back at an empty stack. Then we go into D, so we just have 1 in the stack for D, and then we list those out. I think this should work. Yeah. So let's do this. For the else case, since we know that this is going to be ls output, is the only possible way to get here. At this point, we want to first determine whether this is a file or a folder. And note that folders don't have to, or files don't have to have an extension here. We have some that do and some that don't. It looks like the folders never have extensions, but there's no reason to really distinguish there. So let's just say is command, oh, so we already have our parts on line 10. So we can say if parts 0 is equal to dir. Then we know it's a directory, else we know it is a file. Okay, so either way, we are going to get the full path and push that file into the file system, or file or directory. So let's say, we'll say const dir equals name is going to be parts 1, and type is going to be dir. Okay. And I think that's it for now. Let's come down here and we'll say const file is going to equal name is going to be parts 1, type is going to be a file, and size is going to equal, and since we're definitely going to do math on this, I'm just going to convert it to a number and say parts 0. Okay. So either way, we're going to push that in. So maybe let's say let entry here, so that we can just say entry equals. Entry equals. Okay. Okay, so now that we have our entry, now we want to push it into the correct spot in the file system. So let's grab the directory in the file system. So const containing dir is going to equal our file system at full path. Okay, and then we can say if containing dir doesn't exist, in other words, we haven't been there yet and there's not an array there, then we are going to file system full path. You know, it occurred to me that we could probably put this code up into when we push, because that way we're only doing that check once, right? And so we can say dir is going to be file system full path, and dir. Then file system at full path is going to be initialized to an empty array. This will allow us to keep track of files as we push them in. And then that way we can just say file system.fullPath down here dot push entry. And with that, I don't even think I would need to put anything in here to seed it, because we'll get the full path as empty when we cd to that. Oh, but we would still need to do it here. So let's do this. Let's just move this down here. So it becomes a step that happens directly after the CD. It will make sure that that path is initialized. Okay, let's see what happens when we run this. And yeah, I don't end up needing current working directory at all. I don't think so. Let's do a console.log of file system. Click out of that. Okay, so let's see. Does this resemble what they had there? We've got the slash, which is going to be the empty here, has A, B, C, D. A, B, C, D. A and D are folders. And the others are files, and there's their sizes. Great. And then we've got A, which has EFGH. EFGH. A/E has I. And D has JDDK. JDDK. Okay, I think we are well on our way. I think we've parsed through our input, and we're ready to move on to the solve. So I should probably actually return the file system. Okay, so now we can say const file system is going to equal parse input. And then what do we do with that file system? We want to figure out for each directory how much space it's taking up. So we would say, let's start with object.keys on the file system, because we've got, this is great that we've got kind of a flat structure here. We don't have to worry about doing recursive calls and nesting and stuff like that too much. Well, we may have to do some recursion there, but it shouldn't be too bad. So let's do something like file system, or sorry, object.keys file system. And then we'll say dot for each, and we will say dir goes to. All right, so now we basically want to total up the size of files within that directory and give it and assign that directory a size based on that. So let's think about this a second. The root doesn't have its own entry ever in here. Everything else does. We've got a dir, d dir. I think it's unlikely that the root directory is going to be a candidate for deletion. And so maybe we don't worry about that too much. But we do want to map between the directory and the size. Okay, so let's do this, I guess. Let's look at let's try to just, we'll go through all of these directories. We will find each of the entries in that directory. So dir here is going to be it's a string. So we'll just say const contents equals file system at dir, right? Okay, and then once we've done that, we're going to iterate over that. I'm kind of thinking we might need another function that we can call recursively, because calling solve1 over again is not going to work. So maybe we say export, not export, just function get dir size. We'll pass in file system, and we will pass in a directory, which is going to be the name of the directory. Okay, so if we do that, then we can say const dir contents equals file system at dir, and we'll say maybe we can map each of the contents to a size and then reduce that array of sizes using a summation. So let's try that. So if I say dir contents dot map, he goes to, or I guess it would be C, content goes to so the size of a file, so would be if c.type is equal to file, then we're going to return the c.size. Else, we're going to return get dir size, and we're going to pass it file system, and we're going to pass it dir slash c.name. Oops. Okay, so that should recursively give us that. So we'll end up with an array here of numbers, and then we can say dot reduce, and to do that we'll do previous and current goes to previous plus current. So that way it will call each element in the array, it will give it the previous sum and return that. And so we start with 0 as our starting value. We continue to add each value to the array, of the array to it. Okay, so that should be our size. So we'll say return that. Okay, so then what we can do, we are in JavaScript, which means we can take some liberties as far as we could append additional information onto this array here. Your contents.map. So we could actually just say dir size is going to equal that. We're going to return the dir size. But before we do that, we want to remember that directory size. So we will say dir contents dot directory size is going to equal dir size. Okay, so that way we're keeping track of ones we've already computed. We can actually just go if dir contents dot directory size, then we're going to return it. So that way we avoid having to compute the same one multiple times. Plus it solves the problem where the root, I would have no way of storing the directory size. But since I can just add whatever property I want to onto this array, I can do that. Now, would I normally do that day to day when I'm coding for my job? Probably not. You don't want to conflate types too much. Although I could make a case here that I'm basically extending this type. It's no longer a entry array. It is now a directory, right? So it extends array, but it also has a special property on it. Okay, so then we will say we'll get dir size on the file system, and we'll start with the root. And I don't actually need to get the result from that because I'm likely not going to need it. We only care about ones that are less than, I think it was 100,000. Yeah, at most 100,000. At most, so that means greater than or equal to. Right, okay. So const limit equals 100,000. Okay, and then we will say, so now we can just do a single iteration after we've already traversed the tree and get a collection of those directories where the size is less than or equal to the limit. So again, we can do object.keys. Yeah, I didn't have to do object.keys. And sorry, I was thinking I've already done an object.keys, and I did for a second, but then I removed it and we didn't end up needing it. So we're going to get the file system keys. So this is the names of the directories in a flat list. So even the nested directories end up there. And then we can say filter. Actually, we could just do a map here. We're just going to map and say the name is going to correspond to file system at dir name dot directory size. So we're mapping these keys, these folder names, into their size. So we'll just end up with a number array after this. So we can turn around and say dot reduce. Oh, whoa. No, we don't want to reduce. We want to say dot filter. We only care about sizes where the size is less than or equal to the limit. So we say size less than or equal to limit. And then we can reduce, right? Because I believe we count them up. Sum of their total sizes ends up being that. So reduce, we do the same thing that we did up here. In fact, it's going to be verbatim. This is a standard summation reduction in JavaScript. So then we'll say const total is going to equal that. We can return our total. Now let's try running this, and it blew up. So why is it blowing up? File system at dir name. Is it directory size at get dir size? Oh, I guess I need to say wait a minute. This doesn't make any sense to me. Is it on 42, 49? It's 42. It's here. dir contents is coming back null, or undefined rather. Let's console log some stuff out here and see what happens. So log dir and dir contents. Okay, so we've got the root has dir contents is going to be that. Dir is /a. Oh snap. Because we start at the root, we won't have that. So maybe what we could just do is do the same thing again. We're going to wrap this in an array. We have a dir, and we have stu.name. Dot join on, you know what, I'm being silly. I could just say dot trim start and say I don't want to have a slash character. Is that how trim start works? Leaving white space and line terminator from a string. I guess we could always say that we ignore the first character regardless. So we just say substring 1. Okay, let's see what that gives us. Does it still blow up? We have /e. Okay. A has E. We don't want to get rid of A. Dang it. Okay, we'll do a regex then. Slash start of string, no, sorry, start of string, and then the slash character, and then the end of the expression, and we'll say replace that with nothing. So if it starts with a leading slash, we get rid of it. Oh yay, correct output. I love that. Let's get rid of this console log. And let's plug this in, see if we got what we need to get. Too low. Okay. Sorry, not feeling the best. Let's see. So, let's console log out what the directory sizes look like after we do this. So we'll say console.log object.keys on the file system .map your name is going to become an object with dir name, and size is going to be dir name dot directory size. Let's try running that. Directory size. That should. Oh, it's file system at dir name dot directory size. Yeah. Okay, let's see if those numbers match up with example. So total size of directory E. Oh, I don't even, oh yeah, I do have A/E. It's 584. A has 94853. 94853. D has total of this 249,33642. And finally 483,81165. Okay, so we are getting all of the correct sizes. So what is the difference here? Oh, it's because I copied the wrong one. Oh my gosh. That was silly. And that's the right answer. Okay, now you're ready to choose a directory to delete. The total disk space available in the file system is, we got hundreds, thousands, 70 million. To run an update, you need unused space of at least 30 million. Oh gosh, sounds like a Windows update. You need to find a directory you can delete that will free up enough space to run the update. In the example above, the total size of the outermost directory, and thus the total amount of unused space. Total size of the outermost directory, and thus the total amount of used space is this. Is that what I got here? 483,81165. Okay, that means the amount of unused space is this, which is not quite enough for the update. Therefore, the update still requires a directory with size of at least this to be deleted before it can run. To achieve this, you have the following options. Okay, A and E are too small. Deleting them would not free up enough space. However, directories D and / are both big enough. Between these, choose the smallest, increasing unused space by this. The smallest directory that, if deleted, would free up enough space on the file system to run the update. Okay, this shouldn't be too bad. So we're still going to get the directory sizes. And this actually ends up being our key to part 2, I believe, is this mapping here, because then we can just sort them by size, ascending, so the smallest ones first, and then iterate through and see and grab the first one that gives us enough space. So let's just grab this here and put that in. Okay, so this is going to be our sizes. Sizes is this. So we've got object.keys, then we will map it, and then we will sort it. So we will say and it's wanting smallest D, increasing unused space by this. What is the size of that directory? Okay, so we're not looking for the letter. We don't even care about the letter. We just want the number. So we can actually, we don't even care about the dir name. We could just say dir name maps to the directory size. That does that. Okay, and then sort, we can say A, B goes to A minus B, because this is just sorting integers here. And you can see this sorts the array in place. Negative if the first argument is less than the second argument. So basically, if this is a smaller number, it'll be a negative number. So that does exactly what we want. So sizes, and then we can say const amount to free is going to be I guess we need to figure out the amount of free space we need. So we've got our capacity is this. I'll just write that out so it makes more sense. Capacity is this. Const used is going to be file system at the root dot directory size. Amount to free is going to be our capacity minus how much is used, or I guess we could say free space needed. Okay, cool. And then now we can just say const amount deleted is going to be sizes dot find, which is going to return the first element of the array that matches the function or the test that we are going to write here. And the test is s goes to s is greater than or equal to free space needed. And then we return amount deleted. Oh, and I didn't create my example, so let's, for this example, make this 2 input and the 2 output. Name. So the output for number 2 is going to be this. And so we can just do that. Let's see if it works. It does. All right. This has been a lot of fun. Not the right answer. Your answer's too high. Oh no. Output for example.2.input.text is correct. Okay, so let's do this. Let's come in here. Capacity minus used. So let's just console log a whole bunch of stuff out here. So we will console log the capacity used, free space needed, amount deleted. Okay, so let's make sure that we've got all the right numbers here. So used space is that. Free space needed is this. That's correct. Amount deleted is the first thing. Oh, I also want sizes so I can see that. Sizes, okay, so we skip these two because they're too small and then do that. Well, yeah, it seems to work. Did I guess 409.13.445? Or did I paste the wrong thing again? 409.13.445. Okay. Okay. I guess I come here and let's comment this out so we can actually see what the real one's going to be. Okay, so we have used this much. We need 290, or not 290, it's 29 million. So the first item in the array that is more than 29 million is that. And it said that the answer was too high, is that right? Interesting. Maybe let's join the sizes by like a comma or something, just so I can scan through all of it. unexpected token dot. Oh, right. Sizes is going to be sizes. Okay, so we need 298,655. 290. But I mean, we're still, this is 29 million that is needed. So we already have 40 million. This is 16 million. Wait, what? Oh, we're saying we delete the entire file system. That's not good. Okay, let's look up here. You need unused space of at least, oh. Right, okay. The example wasn't comprehensive enough to get me there. Okay, so we're going to say const needed is going to be that, used is this, free space needed is not capacity minus used, but needed minus used. No. Free space needed is going to be the difference between the needed and the used. Yeah, okay. I think that's right. Did we get incorrect? Okay, so let's see. Free space needed is a negative number. That's great. So it's probably going to be used minus needed. Okay, let's try that again. We have this is correct, and then this. I think that probably is the correct answer. Let's see. Still too high. Okay, so let's see here. So capacity needed, used, free space needed. So on the example, it says the free space needed here is 18 million, right? Total size of at least. Oh, that's not right at all. Okay, so let's see here. Still requires a directory with total size of at least this to be deleted before. So basically we're saying needed minus unused. Oh, right. Yeah, so capacity minus used is unused. Once unused is capacity minus used. Free space needed is going to be needed minus unused. Okay, let's try it now. Do we still have the right answer? Yes. And this is our puzzle input answer. Let's see if that's correct. Okay. I'm going to go lay down and try to get feeling better. That was a fun puzzle. Thanks for joining, and we will see you next time. Take care of yourself.